Today I would like to present, in fact, the joint work of our institutions, so Space Research Center, Polish Academy of Science from Poland, but also the Center for Ecological Research and Forestry Application from Spain. At this point, I need to emphasize that the study is not completed yet, so this presentation will focus mainly on the preliminary results. At the beginning, I would like to present the context of our research. So the main goal is to monitor the environmental condition in Central Africa, and EFTs were chosen as an appropriate tool for this purpose. As already Lluís mentioned, the EFTs are sensitive to ecosystem functioning, and the changes which could be indicated based on them and remain variant categories in land cover maps could indicate an initial degradation process. What in fact is very important in early change detection applications, which can highlight the changes before the degradation is too evident and difficult to reverse. This kind of approach is extremely useful. It's extremely useful in the analysis of the refugee camp areas where the changes are unpredicted in the environment. And in that case, the early warning system can be based on EFTs. The only limitation with which we can deal is insufficient optical data in the time series commonly used for EFT calculation. The cloud cover is the significant obstacle, especially in the frequently cloudy regions. Taking the above into the consideration, we decided to explore the answer to the following questions. So, can we use radar instead of optical data to map EFTs and overcome the problems associated with optical data acquisition? Referring to the Monday plenary session and the speech of Professor Andrzej Rychling, it is impossible to model environment properly without the knowledge what that environment represents. So our study area is located in the northwestern corner of Tanzania, in Kigoma region of the Kakonko district. In the center, there is a Mtendeli refugee camp. It is located in the distance of approximately 30 kilometers from Burundian border. The eastern side of the camp practically border with the GAM reserve, which was not in line with guidelines of UNHCR, which states that the distance from the ecologically fragile areas should be between 12 and 15 kilometers. So the dominant vegetation in the area is a Miambo woodland. There is a lot of actively cultivated fields. In the study area, the deforestation occurred in two ways. One, the trees are cut down to build the camp infrastructure, and the second direction of the deforestation took place informally. Around 70% of all causes of deforestation were illegal farming. So in general, huge areas of forest were cleared in order to establish illegal agricultural fields, and they were after a time abandoned and new areas were searched for. In addition, there is a huge problem with the collection of the firewood in order to prepare the meals for the camp inhabitants, and the refugees introduce a new way how to collect those firewood. So it's namely drying trees. It involves the barking them for the match and then cutting them down. The Kigoma region lies 900 meters above the sea level in tropical climate. It's characterized by the short 4-month-long dry seasons from June to September. The long rains last from October to January, and the short ones from April to May. The average temperature is 25 degrees, and the highest one is noted in September. Currently, Tanzania is experiencing climate change. Temperatures are rising and rains come suddenly and are very intense, what makes even harder for the local ecosystem to support the local population. In our studies, the EFT are being calculated for the limited time period, which corresponds to one growing season, shown here on the slide, as a period from August 2020 until July 2021. In general, this vegetation season is in line with this description, which I already presented you based on the previous slide. But with this feature, I would like to stress two things. The first one are the fixed moment, which refer to the day of the year, indicating the ranges of the successive season, which will be later used for AFT component calculation. So the periods for the wet season, post-wet and dry. And the second one is the extreme value for precipitation, which occurs in February 2021, is the evidence of the changes taking place in the climate. So there we go with the methodology description on the general level. Let's say in our studies, the starting point is the calculating of AFT based on satellite optical data, namely Sentinel-2 with 10 meters spatial resolution and modest 60-day composite of 250 meters resolution. The second step is so-called improvement approach test, which is based on polygons representing male land use land cover classes and Sentinel-1 radar data of 10 meters spatial resolution. You have already seen this description or similar graphs on Lluís' presentation, but maybe someone joined us right now, so I will go through this part. So to present how the EFTs are calculated, I will support myself with the figure from Cazorla 2020. Traditionally, EFTs are mapped using vegetation indices, NDVI or Enhanced Vegetation Index. In our approach, we are using NDVI. And this is important to obtain high accuracy annual time series of the vegetation profile, which is possible with the support of satellite data. And EFTs in general consist of three components: productivity, seasonality, and phenology. So starting from the beginning, the productivity, which is expressed by maximum value of vegetation index in the growing season, and it is calculated per each of the image pixel. Then we have seasonality, which is expressed by the standard deviation of the series of NDVI, and the phenology, which is expressed as the exact day of the year of maximum value of the calculated NDVI. In order to assemble the components, each element is classified into a number of classes, but it's really important to preserve the characteristic of the region. Thus, in our cases, productivity has been classified into three classes based on quantiles. In the same way we classify seasonality, and phenology was classified based on the season determined in the climatic characteristics on the ranges for the wet, post-wet and dry season. In the second part of our analysis, the improvement approach has been tested. We support our work with the selection of several polygons, which represent land use, land cover main classes. And we perform the correlation test between the optical and radar data. On this slide, you can see an example of 4 polygons out of total 40. Cropland, forest, shrub, and grass. The aim was to verify whether any correlation between NDVI and the polarization values of radar data, VV and VH, occurred by comparing the values for the full growing season. On each of the plot, you may see the green lines, which represent the curve for NDVI obtained from optical data, Sentinel-2 and Landsat 8, and a purple and blue curve, which corresponds to VV and VH polarization derived from radar data, Sentinel-1. In each case, the general course of the curves is preserved in the context of the seasonality, but additionally, the Pearson correlation coefficient was calculated, and the highest value were obtained for cropland and shrub, and the lowest one for forests, which stayed for 0.68 for VH and 0.81 for VV polarization. Additionally, in the red box, I wanted to indicate you the time of this heavy rainfall in February 2021, which affects the curves generated based on optical data, while it does not affect the data generated based on radar data. And additionally, we wanted to investigate some disturbance within the course of the curve based on NDVI, especially in the land use land cover class like grassland. And we noticed also that some cases from the field, so typical grass burning, may affect the course of those curves. The result of this comparison give us, in general, the green light for further investigation, so the calculation of AFTs based on radar data. So here I wanted to present the AFT results, but preliminary as a first step calculated on the optical data. You can see on the slide the final AFTs with tabular information on the specified classes for each of the components. In total, we have 27 classes, so 3 per 3 per 3. Left map is based on Sentinel-2 data, and the right on Modi's 60-day product. The highest values dominate in the southeast part, where Goma Reserve with dense homogeneous forest is located, and lower classes might be observed in northwest part of the analyzed area. We can observe a certain consistency between those two results based on optical data. Oh,
1 minute left.
Okay, so going deeper, we can observe also some problems with the day of the year components of AFTs, which is caused by cloud mask and atmospherical correction. This map presents the homogeneous forest area. And in this kind of land cover, we should observe like a stable or semi-homogeneous period of the maximum of NDVI, but instead of that, we can see around artifacts. It's a place where a cloud occurred in a period of maximum NDVI, and then the gap is filled by other dates of the first cloud-free moment. Additionally, you can see on the bottom the histogram, which present the number of cloud-free data for selected polygons, which we were analyzing in the period from August 2020 to July 2021. And you may see that in the rainy season, we deal with just 1 image per month, and in December, it's 0. Here we have the final result based on radar data with tabular information and with additional comparison with the optically derived AFT. We can observe the consistency between the results, but with the dominance of intermediate classes of AFT in the results based on radar data. Let's jump quickly to the conclusions. So the conclusion of our preliminary study are as follows. The AFT derived from optical data present different confidence level in space and time due to the cloud cover. AFTs derived from radar images show general picture, however, some problems have to be solved. For sure, the reclassification rules due to the difference in the histograms showing the distribution of values, and a better investigation or reduction of the noise which occurs in the radar data. AFTs show differences at functioning of drivers of land cover. They are our future plans. So we plan to implement further improvements to perform the data fusion approach, extend the area of interest, and perform change detection based on AFTs and compare it with the changes of land use, land cover in order to determine the area under pressure. Here, just at the end, fast notice about the funds or the project within which we perform the analysis, the references, and really fast going to the end. Thank you for your attention.